OddityRC ECHO5 Basic Settings. In this episode, we'll cover the basic setup of a new flight controller after assembly. First, open Betaflight Configurator. Connect the flight controller to your computer using a Type-C cable. Normally, you can click Connect to enter the configurator. If it fails, manually select the correct serial port and reconnect. Once connected, open the Setup page. Here, you'll see a 3D model synchronized with the aircraft's attitude. First, place the aircraft on a level surface. Click Calibrate Accelerometer and keep the aircraft still for a few seconds. This sets the aircraft's current level position as its reference. The arrow on the model indicates the front of the aircraft. Pick up the aircraft and rotate it in different directions. The 3D model on the screen should move with the aircraft. Check whether the model's movement and attitude match the actual aircraft. If they don't match, open the configuration page. Find the board alignment settings and adjust the flight controller's rotation angle. Use the model's response to determine which direction needs adjustment. This step checks whether the nose direction and flight controller orientation are correct. Next, open the ports page. The entries beginning with UART correspond to the flight controller's serial ports. You only need to configure the UARTs connected to actual devices. In this video, the DJI-O4 Pro is connected to UART 4. Therefore, enable MSP on UART 4. Then select VTX MSP plus DisplayPort under Peripherals. If you're using an analog VTX, select the corresponding control protocol. Next, configure the receiver port. Enable serial ARCs on the UART connected to the receiver. Leave the remaining settings at their default values. If GPS or other peripherals are installed, configure their corresponding ports as well. Next, open the configuration page. Set the PID loop frequency according to the flight controller's performance. An H743 flight controller can generally run at 8,000. For an F405 flight controller, 4,000 is usually more suitable. Higher loop frequencies require more processing power. Choose the appropriate setting for your flight controller. Next, set the maximum arm angle. The default value is normally 25 degrees. This means the aircraft cannot arm when tilted beyond 25 degrees. For example, it cannot take off from a slope steeper than 25 degrees. We recommend setting this value to 180 degrees. This allows the aircraft to arm and start its motors at any angle. Next, enable Air Mode. Air Mode allows the aircraft to maintain attitude control at zero throttle. Many FPV racing pilots leave this feature disabled. However, we're setting up a freestyle aircraft, so enabling it is important. Then enable OSD. OSD displays the required information in the video feed. On the right, we only need to configure D-Shot Beacon. We recommend enabling all the D-Shot Beacon options. It provides aircraft status feedback and helps locate the aircraft. Next, open the PID tuning page. This page is mainly divided into 3 sections. The rate profile can be adjusted directly according to your needs. The other 2 sections require further tuning through test flights. We may cover these settings in a future video. Next, open the receiver page. Set the receiver mode to serial. Select the protocol that matches your receiver. Here, we're using an Ehlers to point for GHz receiver. Therefore, select Cursive as the receiver protocol. Make sure the channel map is set to a ATR1-234. Leave the remaining settings at their default values. You can bind the receiver and radio directly from this page. Click Bind Receiver in the lower right corner. You can also power cycle the aircraft 3 times to enter binding mode. Once binding is complete, check the stick preview on the left. Move the sticks and confirm that the aircraft model responds correctly. Next, open the Modes page. This page assigns different aircraft functions to the radio channels. In this video, we'll configure several essential channels. ARM is used to arm the aircraft and start the motors. Click Add Range to display the adjustment slider. Use the slider to set the function's activation range. The yellow marker below shows the current position of the radio channel. When the yellow marker enters the selected range, the function becomes active. The other channels are configured in the same way. Angle is the self-level mode. When the sticks return to center, the aircraft automatically returns to level. Beeper is the aircraft's beeping function. It helps locate the aircraft and confirms whether the radio is connected. Next, open the motors page. This page is used to configure the motor order and rotation direction. First, select the mixer type. For a standard quadcopter, select Quad X. Then select D-Shot 300 or D-Shot 600 according to the flight stack's performance. First, click Reorder Motors. Make sure all propellers have been removed before continuing. The aircraft must also be connected to a battery. The arrow on the screen indicates the front of the aircraft. The system will now spin one motor at a time. Click the corresponding position based on which motor is spinning. Repeat the process until all 4 motors are correctly assigned. Then click Save. Next, configure the motor direction. You can use the Setup Wizard or test each motor individually. Here, we'll test each motor individually. The numbers on the page represent the motor order. Press and hold a motor number to spin the corresponding motor. Lightly touch the motor to determine its rotation direction. Then compare the actual direction with the diagram on the screen. If the direction is incorrect, press and hold reversed to change it. If it still hasn't changed, press and hold normal. Continue until the motor rotates in the direction shown. Repeat the same process for the other 3 motors. After making the adjustments, check all 4 motors again. Make sure both the motor order and rotation direction are correct. Next, open the OST page. Here, you can choose what appears in the video feed during flight. This can include battery voltage, throttle position, and signal status. You can also configure warning messages on the right. Select the information according to your needs. Drag each item in the preview to adjust its position. Finally, configure the video transmitter. HD digital video systems don't require settings on this page. If you're using an analog VTX, configure it on this page. Here, you can adjust the frequency band, channel, and output power. First, import the correct VTX table. The VTX table file should be obtained from the VTX manufacturer. Click Load from Clipboard or Load from File in the lower right corner. Import the correct VTX table file. Once imported, you can adjust the frequency band, channel, and output power. At this point, all the basic parameters of the flight controller have been configured. If you have any other questions, feel free to leave a comment or send us a message.